Hey everybody, today what you see here is a clip from a bigger video on solving linear equations. And what you're going to see is the solutions to two equations that have got a bunch of brackets in them, some simplifying. These would be your doozies of the middle of the road, okay? I hope they help out. Good luck. Okay, question E and F got considerably longer in terms of the width of their problem, so they're going to look a little smaller on your screen. We're going to go through a solution to E. Now, there's one big theory mistake, and this is going to be one that I'm honestly going to say to you, I wouldn't be that concerned. I threw in question E for a reason. Okay, we take a look at both sides of that equal sign, and I'm just going to highlight that equal sign. Because I'm hoping that we've gotten into a little bit of a practice that what we want to do is we want to simplify both sides of that equal sign before we start going through and trying to isolate variables or variable terms. So I notice on the left side, I can expand in my 4. Okay, the left side of my 4x plus 8, I still have that plus 4 equals. Now on the right side, I could do the same. I just really hope we didn't do this and expand in a 5. If we made that mistake, I'm telling you, you failed grade 6. And as soon as I say you failed grade 6, everybody should be going, oh shoot, that was a BEDMAS mistake. So what was my mistake? Well, up in the question, the original equation, I had an addition operation here, and I had a multiplication operation here. So we should now be able to see, oh shoot, I just added before I multiplied. I broke BEDMAS. So the reason why I wanted to cover something that looked like E was because that is such a common mistake that I think we just get a little too eager within this equation setting, and we want to put that 3 and the 2 together. So fight the urge. We're not going to do that. We're going to be patient. We're going to leave that 3 out in front, but we can expand in the 2. Now, this line is never needed, ever, ever, ever. But I would suggest it. I don't think it slows you down that much, and therefore it doesn't make it inefficient to spend one line in our solution fully simplifying both sides of the equal sign. Like, let's clean it all up. Because if I do get into the practice of simplifying both sides, then in this case, I'm only going to have to do 2 opposite operations. Okay, I take a look at my x terms, my variables. I notice if I put everything on the left, I'll have a positive coefficient. So I have 4x minus 2x, there's a 2x. That means I have to deal with my constants on the other side. I already have a minus 5 on the right side, and I need to get rid of the plus 12. To get rid of a plus 12, I have the minus 12. There's my negative 17. Now to finish it off, all I have to deal with, to get rid of my times by 2, I divide by 2 and I'm good. I would love it if you had that solution in gold. And I think if you did, you've got a pretty efficient solution. I just want to draw back to your attention that first line we did. And I'm hoping you can see by just spending one more line to simplify both sides, we don't have to do 1, 2, 3 opposite operations. That we would have had to look at that and get, okay, to get rid of a plus 8, I have to minus 8. To get rid of a plus 4, I have to minus 4. Then on the other side, to get rid of a plus 2x, I have to minus. That we were able to do fewer opposite operations. So that's why I say spend one line, go through and clean it up. You don't have to, but you better bet that if you make a mistake, the first thing I'm going to write on your page is like, why didn't you? Okay, I think I may have jammed some people on question E, and so we may be at a point where this is a time to pause it and give F another try. Okay, I'm going to give you a moment to pause it. Make sure we have a full solution to f. Pause it now. Okay, we're back. So I am hoping that this is just pure confirmation now. Okay, we can expand in the 3 on the first brackets. We now are not going to touch that 6n, and now we're going to expand in our -3. You take a look at my line, and I am hoping that you are screaming at your screen right now because you noticed there was my goof. When I expanded in that -3, a -3 times a -n is going to give me a positive 3n. I would argue in this problem, that is now your most common mistake. Notice, nobody makes the BEDMAS mistake up here because you couldn't put the 6n together with the -3 anyway. It's going to be your sign mistake on the end, so watch out for it. Okay, we spend one line cleaning some stuff up. Collect like terms on both sides. Oops. And I can't... See, there's a great example. Say I went through and I put my 6 together with my 3 and I wrote 3. I accidentally subtracted them. I'm not concerned about that at all. No, before I went to erase it, now you have a half of a 3 there. I am not concerned about that at all. That's a silly mechanical mistake. Ugh. Okay, I keep working to try to get better at that. Make fewer of them. Remember what we said at the beginning? Be better than what you were before. That's not a theory mistake. Okay, but luckily I caught it. And I was able to take my 6 plus mine. Oops, now I'm in red. And there we go. Okay, I'm going to put up 2 final solutions just to make sure that we're good. If we are dealing with positive coefficient people, then we should be viewing our variables on the right. I got to get rid of a plus 3n, so I'm going to minus 3n, 9 minus 3, 6n. That means I have to put my constants on the left. So I got to get rid of that minus 15, so I'm going to add 15. And now to get rid of a times by 6, I'm going to divide by 6. And we got a nice, neat integer in that case. Okay, what was the other solution? I'm not under an illusion that I've got everybody working with positive coefficients. Even though I've tried to push you that way, I think I still have a bunch of people that are probably going to be left side variable. So from the line that I just started, I'm just going to go through and put up a left side variable situation. Okay, so I go through and I would have a -6n on the left, and I would have a -24 on the right. Now when I divide out, my negative divided by my negative gives me a positive, and so 24 divided by 6 is 4. You can see that in that case, there's no extra line that we had to simplify or reduce on. And so I might have some people that go like, why is Gray just harping on this positive coefficient? I want you to take a look back at E, because I want you to see that if I put my variables on the opposite side, I have to be careful of something. So I'm going to put in an alternate solution as if I went and put my variables on the right. Okay, so on the left side, I would have a positive 17, and on the right side, I would have a negative 2x. Okay, now for me to solve that, I need to get rid of my times by -2. So I divide by -2. And I hope that you can see you're wrong. Now, I don't mean wrong is incorrect of the value, but your form is horrible because we know you can't have a negative value on your denominator. So it forces you to just be conscious of that. Notice, look back at my gold solution. Because I had a positive coefficient on my x, I was dividing out a positive value, and therefore I never had to worry about a negative on my denominator. Ideally, you would be looking at that blue equation anyway and saying it's a positive 17 divided by a -2. So a positive divided by a negative is negative. 17 divided by 2 would not reduce, and so you come in on the blue. Okay, I think I threw a bunch of stuff at you guys today, but we definitely took a big leap in the sorts of equations we can solve. Your job, jump in and get as much practice as you can, making sure you are comfortable solving equations that take these forms. So be very discriminating about what practice you do today. Do you need some practice with just some basic equations with variables on both sides and so on? Or did you nail out a bunch of these last problems and you feel really confident to say, you know what, I can jump right in on the ugly stuff and get some practice with that right away? Okay, you figure out what practice you need to do to make sure you can excel at this stuff. Okay, best of luck.